Hello, everybody. We continue our workshops topics about GDPR compliance. And one of the important stuff which I wanted to talk with you separately, it's encryption. So how to protect your data in AWS using encryption methods. Few words about myself. I'm working as CTO and co-founder of the Bit company, and already work with AWS about 6-7 years. So that's why today I will talk with you about part of AWS ecosystem, and we will start firstly about what actually encryption methods we will have. Which we have and what are the difference and how they work. And after that, we will put together these methods with AWS services, which will help us actually use these encryption types. And first encryption type that I want to talk about you is encryption on fly. Here you can see the schema, and I think it's very good show how encryption on fly work. So when you, for example, pass your credit card data, of course, you don't want that anyone one who have access to network will see it. So you want that it will be hidden. So what you do, you before send the data, you encrypt it, you send it encrypted, and then, for example, on the website or in the server, you decrypt and see what are the actual data. In most cases, it's can be achieved with HTTPS, and now is the standard. So HTTP is very unsecure and maybe only for staging environment. So I would say that it's common in our life. Next type is server-side encryption on REST. In this case, what we have also, you can see it on the schema, we have object, and we have some key which will be used for encryption. And we send object to the server by using a key encrypted, store it in the server with an encrypted format. Then by using the same key, decrypt and send back, I would assume in most cases is a client. But anyway, send it further. In this case, yeah, as I said, encrypted received by the server and decrypt before sent back. It store encrypted format thanks to the key, and encryption and decryption key, which I already mentioned, should be stored somewhere. About the methods where to store it, this is actually part of AWS account, and we will talk about it after a few minutes. And the third big part is client-side encryption. So the main idea that you have on the client side, you have object, you have key which you stored already on the client side, you encrypt it, you send it, for example, to the server, S3, EC2, anywhere. It's stored in encrypted format, and this service does not have any idea how to decrypt it. You send in the same format back. On the client side, it again, together with the key, decrypted, and we have the actual data. In the most cases, to achieve all this encryption methods in AWS, you will use KMS service. KMS service is fully integrated with IAM authorization, and the other benefits is that you can audit API calls with CloudTrail. So what type of keys the KMS have? First one is symmetric, and actually what this means, it's you have one key for encryption and you have the same key for decryption. User can get access to the key only by using KMS API. And the services which you will use, AWS services that you will use, all use symmetric keys. Next one is asymmetric key. Based on the name, it's not the same for encryption and decryption. So it's use public key to encrypt data and private key to decrypt the data. In this case, public key could not be downloaded on KMS, but access, and no access to private key without API calls. And encryption should be done out of AWS cloud. And okay, so what type of there are 3 types of KMS key which we can use, like other types. So in this case, we will separate them to such parameters. So first one is AWS managed key. It's actually one which integrated into the services. It have such a kind of pattern. So we have AWS/service name. For example, AWS FDS. It's free to use. It's benefit, but of course you can create your custom key. Here, pay attention that each custom key will cost you $1 per month. You can download it and, for example, use for some encryption that you will do like locally. Then you can upload it somewhere and then decrypt it again, and by using KMS API. And the third one is CMS. The key which is imported is also cost $1 per month per one key. It should be 256 semantic key. The difference is that it's not generated on AWS. You generate it somewhere else and then upload for KMS for storing. Important thing that I want to mention here is about automatic key rotation, because most of the compliance needs this requires this action, and AWS provide rotation update of the key each year. It's by default in case that AWS managed key. If it's custom key, then you need enable it. So when you create custom managed key on AWS, you just need to, there is a checkbox, you just need to check, yes, I want to update it each year. And important that you can change the frequency. So it's always 1 year. Also, it's important to know that if you not provide the right policy to KMS key, it will not be accessible. That's why let's check for which actually policies we have. And there is only 2 of them. First one is default. And when default policy is created if you don't provide custom policy. Very easy. And by default, it gives access to everyone in account to access the key. So it's not very secure. If you can, in custom policies, of course, you can define users, role, who can access key, or, for example, define who can administer the key. So for security and for compliance, it's better to use custom policies. Want to pay your attention that same KMS key can be used through different regions. So here in the schema, you can see that if we want to copy volume from one region to other, key will be different. So we have in one region, we have key A. We create a snapshot from the volume. It's still key A, but when we copy, actually during the copy phase, we change it to key B. And snapshot appear in the different region with key B, and then you create a volume again with key B. Now let's look to some AWS services which support encryption, and let's see what what special it have about the encryption. So first is AWS. So AWS is web service that provide block level storage volume to use with Amazon Elastic Computer Cloud. In most cases is like hard drive. There are a lot, okay, not a lot, for different type of AWS, and let's check which actually encryption important item we have in AWS. So first one is if you will enable encryption in AWS volume, data is in rest. So the second time that we have talked about today is inside the volume. And all the data in fly moving between these instances and in the volume is encrypted. Also, all snapshots are encrypted, and all volumes created from screenshot are encrypted. Also, encryption and decryption are handled transparently, which means that you don't have to do nothing to do it. It's everything done behind the scheme, which is very, very comfortable. Encryption has minimal impact of latency. Also, encryption leverage came from KMS. Copying and unencrypted snapshot allow encryption, and snapshot of the encrypted volume is encrypted. So partly we see it in the schema that just on the previous slide we discussed. So when we copy, we see the different type, and it's still encrypted if you create it by default. The steps to encrypt AWS volumes are very simple. You create snapshot of the volume, encrypt the snapshot, create AWS volume from the snapshot, and attach encrypted volume to original instance. It's about the storage. About the server. Let's talk about a little bit about S3 encryption. What important here? There are not one type of encryption. There are four of them, and they are a little bit different. So let's firstly go through them quickly and then check deeply. So first type of encryption is server-side encryption with managed keys. So in this case, encrypt S3 object using key, handled, managed, and owned on AWS. Second type of the server-side encryption is by using KMS, key storage also in AWS. Third type server-side encryption is with customer-provided key. Very similar to KMS. You also have something by default. You can create your own, or you can upload your own. And fourth type is client-side encryption. So let's dive deep into them and check how they work. So first one is server-side encryption with Amazon S3. So how it works? You have some key. You have some file which you send to S3 bucket. When object appear in the AWS, it's take S3 key, encrypted, and store actually in the S3 bucket. What is unique for this type of encryption? So encryption are made by using key, handled, managed, and owned by AWS. You never have access to this key. Object is encrypted server side by AWS. Encryption type is IES 256. And if you want to encrypt object, you need to send it with specific header. Actually, the header is XMZ server-side encryption. And then you write details AES 256. And it will request AWS encryption object for you. Second type is by using KMS. Very similar approach. On the client side, you have a file, you send it with specific header. When it appears on AWS, it's merged together with KMS key and put into the S3 bucket. What is unique for this type of encryption? Encryption using keys handled and managed by AWS KMS, of course. KMS advantage is user control, audit key usage using CloudTrail. So you can see when anybody use your key with the CloudTrail logs. Object encrypted on server side, and you need to send specific header, and this is different from previous example. So again, IMZ server-side encryption, but here you need to write AWS and then specific key which you want to use for encryption. And here are some limitations. So first of all, you can have some KMS limits. So when you upload the file, it generates a data key with KMS API. And when you download some file, it uses decrypt KMS API. And for the calls, you will have a quota. So it's something like 5,500, 10,000, 30,000 requests per second based on the region. You can increase quota in quotas console, but just take in mind that it's not unlimited. Next type of encryption key is client-provided key. So you user upload file with a key. AWS will use client-provided key as an object to create an encrypted object, and again, to read the file, to read the file, you will need this key. This key again. Sorry, 1 minute. Okay, so what are so what here are the important notes which you need to remember is that it's server-side encryption and key fully managed by client. Also, Amazon S3 does not store the encryption key you provide, and after you will use the key, it will be discarded. HTTP need to be used because we send the key to S3, and of course, it will be not secure if somebody will read the key. And encryption key must be provided in HTTP headers for every request that should be made. Next one is client-side encryption. So here the main point is that you take files on the client side, you forcefully encrypt it, you get encrypted file, and you send it to S3 bucket. It's stored as it is without any changes. You can use client libraries such as Amazon S3 client-side encryption library for encryption, and customer fully need to manage the keys and encryption cycle. So AWS does not responsible for key storing. Also, Yeah. Want to give you some notes about encryption in transit with S3. So S3 support two types. Encryption in transit is made with SSL certificates, and Amazon S3 support two HTTPS and HTTP endpoints. Of course, HTTPS recommended is mandatory for SSE protocol. So when you move from staging environment to production environment, don't forget about these important details. And also, I would want to mention about the compliance. I already talked about it a little bit. So based on share responsibility model, AWS will not guarantee you the compliance that you are going according to any compliance. So you need to check which compliance you have and make the changes according to it. I will give you some example. So first is payment card industry data security standard required that card information will be encrypted in transit in the REST. Similarly, is for HIPAA compliant. It's for healthcare in US. It's also they say that it should be encrypted in transit and REST. GDPR does not have a very strict requirement, so they don't say that it should be encrypted in transit in the REST, but they say that it's important that you use site secure level, which will protect data of your users. So even if it's not with the open text, it's still behind the scene is actually the same as required. AWS, I want to pay attention, have a lot of compliance certificates. So from this point of view, it's everything okay, but don't forget that you need to remember what your compliance need from you. That's all from my side for today. It was not long. Please follow me in LinkedIn and follow our group in the LinkedIn. Write me what interesting for you so we can prepare the material and maybe discuss topic which more close to your business cases. In this case, it will be maybe more relevant to you today. If any questions, I will be happy to answer. Okay, good. Then see you in closest week. Have a nice evening.